Hi, thank you for the opportunity to present the work of my students and myself to a decidedly more applied ecological audience. I will talk about seascapes in coral reefs in the Philippines. Like our terrestrial counterparts, marine scientists in the Philippines deal with an incredible variety of species found within our borders. It helps that we are in the coral triangle where half of the coral reefs in the world are found. And since coral reefs harbor a quarter of the marine life, that partly explains the richness of species within our waters. And like the counterparts on land, seascapes in the Philippines have corridors, patches, and mosaics of communities found in coral reefs. These assemblages differ from place to place and all require some kind of explanation. Explanations that will help us manage and conserve them better. And like our counterparts on land, we ask the same questions. Why do we have so many species? And what allows these species to coexist? In 1979, Joseph Connell summarized 6 theories to explain the diversity in tropical forests and coral reefs. These 6 theories were divided into two. Two are equilibrium theories, and 3 are equilibrium theories, and 3 are non-equilibrium theories. Non-equilibrium in the sense that the theories involve disturbances. As we revisit these series, it is obvious that we need to consider the spatial context in understanding which of these theories likely applies in given situations. For example, if we look at patterns in coral reefs at the meter and sub-meter scale, where the circular networks theory likely applies. The circular network theory explains diversity and the coexistence of species despite a competitive hierarchy where A outcompetes B should they grow together, B outcompetes C should they grow together, C outcompetes D. If D is able to outcompete A, then the 4 species can coexist despite the existence of this competitive hierarchy. And since corals are very aggressive animals competing for space, we examined the arrangement of these corals in space. We examined 2 depths in Puerto Galera and found that the arrangement of benthic categories in the shallower depths, which are more crowded, were decidedly non-random. However, if you look at larger scales, at the tens to hundreds of meters, like the counterparts on land, where there's vertical stratification, we also found that if you look closely at assemblages of corals. There's a clear pattern related to depth and exposure to waves. But these patterns can get erased. For example, when there's an abundance of these coral predators, the crown of thorns starfish, which prefers the fast-growing corals, the community assemblage will change very quickly, but closer examination shows these predators prefer the fast-growing corals, allowing the slow-growing dome-shaped corals to persist and not be outcompeted. So these explorations suggest that the equilibrium theories apply mainly at smaller scales, especially in crowded, benign, homogeneous environments, which can be found, for example, in lagoons and certain reef slopes. At larger scales, however, this time in the scale of hundreds to thousands of meters, the non-equilibrium theories likely apply. Early work for my master's thesis showed, for example, that coral communities, particularly in embayments, are organized in a manner consistent with the degree of embayment, which is related to how much exposure they get to strong waves and currents. And these forces lead to non-random distribution of corals and other benthic categories in a manner very similar to even broader patterns that you can find across the Great Barrier Reef of Australia as you go farther from the Australian continent. And going back to the Philippines, where we have climate types on land, work of Dr. David and others show that there are similar climate types in the sea. We thus sought to examine whether this leads to distinct distribution of coral communities. However, because we are not clear about the spatial scale at which these communities are organized, we try to answer the question about patterns with a hierarchical sampling design where we have transects embedded in stations that are about 2,000 square meters in area. We have two stations a few hundred meters apart that are embedded in sites, and we have 3 to 7 sites within a location which typically corresponds to embayment or municipality. If you look at hard coral cover across this hierarchy, the individual dots here representing 50-meter transects embedded within stations, stations embedded within sites, and sites embedded in 4 locations: Bolinao, Pangasinan, Lian, and Mabini in Batangas, and Tubataha, our largest and best managed marine protected area. There are no obvious patterns with coral cover, the abundance of coral. But if you look at the diversity, the richness of taxonomic amalgamation units, which are essentially genus growth form combinations, you will find, for example, that diversity in Bulinao is often much lower. Diversity in lian is unusually high, better than Mabini and even Tubataha, and closer inspection suggests this has to do with the disturbance history between Bolinao and Lian, particularly ocean warming and human impacts. But within Bolinao and Lian, there are clear inshore-offshore gradients of human impact. It's also clear that Mabini benefits from the currents and upwellings, which reduces exposure to warm waters during bleaching events, and that Tubataha benefits from its remoteness and protective management. So disturbance is key at larger patterns, and we start seeing the role of human activity. And so if you look at the whole country level, which we got to do in the recently completed National Assessment of Coral Reef Environments, where we got to visit reefs in 206 stations around the country in 6 biogeographic regions. We found that the excellent category reefs of 40 years ago do not exist anymore because we have lost about a third of our coral cover, especially in the last decade. But even with that loss, likely associated with climate change and human impacts, some bioregions are doing better than others. The Sulu Sea and West Philippine Sea bioregions are richer than the rest, and the South Philippine Sea bioregion, for some reason, is not doing very well. If you look at the composition of the coral communities in these places, as they are classified among 4 hard coral cover categories, you will notice that the stress-tolerant corals are most abundant in reefs with lower coral cover. But in the best reefs, they're only number 3 in terms of abundance. The better reefs are dominated in part by branching acropora, the staghorn corals that are very competitive species. In contrast, the stress-tolerant blue coral, which makes up about 40% of the corals in Bolinao, they become more dominant in the lower cover categories. These patterns suggest that the non-equilibrium theories apply at larger scales and in disturbed heterogeneous environments. And at these scales, we have to be concerned with human impact. Spatial scale is important, but human impact must not be forgotten. Finally, I would like to show how this relates to recent work by one of my students. She classified the 206 reef stations surveyed during the national assessment I presented earlier and found 7 community types, 4 of which we will cover in the next few slides. Type 1 and Type 2, the most common ones in her analysis, turns out to be on reef slopes that face the southwest and the northeast monsoon, whereas the Type 3 and Type 4 are in more wave-sheltered areas. If we examine these communities in terms of rank abundance diagrams and see how the abundances of the species relate to each other in terms of relative abundance, to find out which communities have greater evenness and which communities have clear dominance. If you relate this to the 6th and arguably most famous of Connell's 6 theories, the intermediate disturbance theory, which suggests diversity is highest in areas with an intermediate level of disturbance. It appears the Type 1, dominated by the southwest monsoon, or controlled by the southwest monsoon, is the most diverse. Type 2, which is controlled by the northeast monsoon, is second most diverse. And the wave-sheltered Type 3 and Type 4 have lower diversity, and it may be due to the fact that disturbance, especially those that create strong waves, are less in the places where these communities are found. This pattern allows us to propose a generalization of sorts on how reefscapes are organized in our waters. If you have an island with circular shape, the northeast side will have a Type 2 community, the southwest side will have a Type 1 community. If the island is more elongate, these communities are going to be more extensive. If the orientation of the island is to the northwest and the southeast, if the island is oriented this way, you will have at least 3 community types. Type 1 in the side that's facing the southwest monsoon, Type 2 in the side that's facing the northeast monsoon, and Type 3 in the areas that are parallel to the monsoon winds. If you have an embayment oriented or facing the northwest or the southeast, you'll likely just have Type 3, maybe Type 4 communities. But if this embayment is facing the southwest, you will have Type 1 communities in the low embayment ends and Type 3 communities in the bay head area. If the bay is facing the northeast, you will likely have type 2 communities in the low embayment areas, and depending on the length of the bay and likely the depth, you will have either type 1 or type 3 communities or both in the area nearer the bayhead. And if you have clusters of islands like in the Visayas, you will have this mix, again type 1 facing the southwest, type 2 facing the northeast, and type 3 in the areas between these islands, areas that are more sheltered from waves. So what I tried to show here is the organization of seascapes or reefscapes in our waters is predictable, non-random. These non-random patterns are likely driven by factors or forces that may or may not involve disturbance. And this means we have to keep these factors in mind when managing or trying to conserve these coral communities. These coral communities management requires an understanding of diversity patterns and community types, not just coral cover. And unfortunately, management of our reefs is still very much focused on cover and almost ignores diversity. And that is the lesson that our work is reminding. So again, I would like to thank the organizers of INREM 2021 for the opportunity to present to an audience such as this. I would also like to thank the organizations that funded much of this work over the years, particularly the Department of Science and Technology, especially PICARD, DNR, the Commission of Higher Education, and De La Salle University. Again, thank you and good day.